Hi, and I welcome you to our first discussion. Before I start, I would like to formally acknowledge my source, Fundamentals of Statistics by Diego M. Amid, PhD. The majority of the terms used in this discussion will be primarily taken out of this book. So, with that said, let us continue with the discussion. Descriptive statistics refers to the methods of organizing, displaying, and describing data by using tables, various graphs, and summary measures. So let us look into an example. A study conducted a survey in which the researchers analyzed the following data. 90% of the respondent population are employed, while 10% are self-employed. As you noticed, the interpretation mainly described the pie graph. Next example is a table presenting the relationship of absences to the academic performance for the subject English. Again, the interpretation mainly described what data there was on the table. So recap, descriptive statistics refers to the method of organizing, displaying, and describing data by using tables, various graphs, and summary measures. Our next discussion is all about inferential statistics. Inferential statistics uses methods that use sample results to help make a prediction. This also works with generating a hypothesis or an inference. So for our example, for inferential statistics, was derived from MSA Chapter 9, Hypothesis Testing. A diet clinic states that there is an average loss of 24 pounds for those who stay on the program for 20 weeks. Use the standard deviation of 5 pounds. The clinic tries a new diet, reducing salt intake, to see whether that strategy will produce a greater weight loss. A group of 40 volunteers loses an average of 6.3 pounds each over 20 weeks. Should the clinic change the new diet? Use the significance level of 0.05. So we use inferential statistics in order to arrive or come up an inference or a prediction. We are then able to generate an inference. Reducing salt intake will not produce a greater weight loss. So recap, inferential statistics uses methods that uses sample results to help make a prediction. Our next discussion is all about variables. But first, what is a variable? Well, according to the Australian Bureau of Statistics, variables are any characteristic, number, or quantity that can be measured or counted. While Diego M. Amid states that variables are any characteristic under study that assume different values for different elements to a variable. Now, there are generally two types of variables. First is the quantitative variable, while the second one is the qualitative variable. Quantitative variables are variables that can be measured numerically, while qualitative variables are variables that cannot assume a numerical value. So the main so you can see the main difference between the two. The quantitative variables can be measured numerically, while the qualitative variables cannot assume a numerical value. Let us look into the quantitative variables. Quantitative variables generally have two subsets. First is discrete variables, and second are continuous variables. Discrete variables are variables whose values are countable. Another definition would be that discrete variables are variables that can only assume certain values with no intermediate values. So example of a discrete variable is the number of cars sold in a year. While continuous variables are variables that can assume any numerical value or interval. An example of continuous variable are temperature and interval between a second and a minute. For our next presenter, let me introduce to you Mr. Justin Avila.
Thank you for that wonderful introduction, Mr. John Emmanuel Arsenas. Now, for our next topic, I would like to discuss to you the levels of measurement. Now, the levels of measurement has four types. First is the nominal scale, second is the ordinal scale, third, interval scale, and the last is the ratio scale. Let's first discuss the meaning and some examples of the nominal scale. A nominal scale is a measurement scale that classifies elements into two or more categories or classes. Now, basically, a nominal scale it will it will categorize each element or each individual into categories or classes. As you can see here in the example, the respondents or the individuals were classified according to their religion and their gender. Religion being Roman Catholic, Buddhist, Protestant, and Jewish, and gender being male and female. Next type of scale is the ordinal scale. An ordinal scale is a scale of measurement that ranks individuals in terms of degree to which they possess a characteristic. Now, compared to the nominal scale, this ordinal scale will rank the individuals or the respondents instead of categorizing them. As you can see here in the example, the individuals were classified or were ranked rather according to their anxiety level of mentally retarded patients in hospital Y. So the ranks are as follows: 0 being not anxious, 1 low anxiety level, 2 moderate high anxiety, 3 high anxiety level. So just a recap before we proceed with the last two topics. Nominal scale classifies the elements or the individuals. It will categorize them, and ordinal scale ranks the individuals. Now, before we proceed for our last two topics, I would like to first discuss to you the meaning of absolute zero. Now, absolute zero means that the number zero has no meaning. You will further understand the meaning of absolute zero as we go on with the discussion. Interval scale. An interval scale is a measurement scale that in addition from ordering scores from highest to lowest, establishes a uniform unit in the scale. There is no absolute zero in the scale. Example being temperature. Now, to further discuss interval scale, I will compare it side by side with ratio scale. A ratio scale is a measurement scale that, in addition to being an interval scale, also has an absolute zero in the scale. Examples: height, area, weight, and speed. Now, after all these two topics, what is absolute zero? In interval scale, it is said that there is no absolute zero in the scale. No absolute zero. And if we will go back to the definition, absolute zero means that zero has no meaning. So what this is trying to say to us is that in the interval scale, absolute zero means something. Example, temperature. Why? Because in temperature, 0 degrees Celsius or 0 degrees Fahrenheit actually means something. It means that it is cold. Ratio scale, on the other hand, has an absolute zero in the scale. Examples being height, area, weight, and speed, meaning that that zero in the ratio scale doesn't mean anything. Why? As you can see here in the example, height, it is impossible for something to have zero height. It is impossible for something to have zero weight or zero speed. So to further so to further have a recap on what we discussed rather, nominal scale classifies elements, ordinal scale ranks individuals, interval scale there is no absolute zero, ratio scale has an absolute zero. For our next instructor, I would like to introduce to you Miss Shaira Blancaflor.
Thank you for that wonderful introduction, Mr. Justin Avila. Now, the next topic I will be discussing is summation notation. Summation notation is used to denote the sum of a given set of values. In summation notation, we have this equation. This basically means the sum of the value of xi that starts with 1 and ending with n. Now, n will be the stopping point. I equals 1 is the starting point. And this one is what you call the sigma or the summation notation symbol. When we see the sigma or the summation notation symbol, this instructs us to sum the values of a given range. For example, we have this equation. The sum of the value of xi starting at 1 and ending with 5. So here are the given set of data. Now we will be starting with x sub 1 plus x sub 2 plus x sub 3 plus x sub 4 plus x sub 5. And now we will be transposing the given set of data with the sample data. 8 plus 9 plus 12 plus 15 plus 6. And now we will get the total sum of this data. The answer will be 50. Next, we'll be heading to the other example.
Go.
The sum of the value of 8 x sub I starting at 1 and ending with 5. So in this equation, we will be applying the PEMDAS rule, which stands for parentheses, exponent, multiplication, division, addition, and subtraction. So now, we will expand the equation. 8 times x sub 1 plus 8 times x sub 2 plus 8 times x sub 3 plus 8 times x sub 4 plus 8 times x sub 5. And now we will transpose the data. 8 times 8 plus 8 times 9 plus 8 times 12 plus 8 times 15 plus 8 times 6. Now we need to, because of the PEMDAS rule, we will be multiplying first before we add. 64 plus 72 plus 96 plus 120 plus 48. After adding all this, we will be getting 400. For our next presenter, I would like to introduce to you Mr. Rovi Valenzuela.
Thank you for the warm introduction, Ms. Shaira Blancaflor. The next topic that I will discuss is all about sampling techniques. Sampling techniques. These are techniques on methods on how you get a sample from a population. Usually the population is too large for the researcher to attempt to survey all of its members. A small but carefully chosen sample can be used to represent the population. The sample reflects the characteristics of the population. Sampling methods are classified as either probability or non-probability. Let's first discuss probability. Probability. In probability samples, each member of the population has a known non-zero probability of being selected. An example of probability sampling is a fishbowl method, where everyone has an equal chances of being selected. There are 4 types of probability sampling. First is the simple random. It is the purest form of probability sampling. Each member of the population has an equal and known chances of being selected. An example of simple random is a lottery. Second is a systematic sampling. In systematic sampling, there is a system, order, or interval in choosing the sample. An example is, out of 25 students to be chosen, it should be every fifth person. Third is the cluster sampling. In cluster sampling, different groups within a population are used as a sample. In this example, 25 boys and 25 girls. And lastly, stratified sampling. In stratified sampling, the population is divided into groups based on some characteristics. Then within each group, a probability sample is selected. In this example, 25 boys and 25 girls, each one person is randomly selected from the groups. So the above mentioned sampling techniques are under probability. Now we will discuss sampling techniques under non-probability. Non-probability. In non-probability, so in this sampling, we do not know the probability that each population will be chosen. It has three types. First is the quota sampling. In quota sampling, there is a specific target. After getting the target, the sampling stops. An example is, your target is 100 people to survey. Even if there is 1,000 people, you stop at 100 because that is your target. Second is purposive sampling. In purposive sampling, you have a purpose on reason for research. These are also known selective, judgment, and subjective. An example is, pregnant woman is your target because the purpose of the research is pregnant woman. And lastly, convenience sampling. These are convenient to the researcher. Researcher will just pick a member from the population that they felt convenient with. An example is a survey given to the researcher's relative. The researcher is more comfortable with the relatives because they know that they'll get a good answer. So, thank you for listening to our group, especially Professor Dexter Umil from San Beda Faculty, and to you all who are watching. Thank you.